Okay. Good evening. Hopefully, you're not seeing my face, but you're listening to this lecture on evidence in science, recorded for JS 110 Introduction to Forensic Science. We're recording this in the fall of 2017. So if you're accessing this archive lecture in future semesters, all the material still applies, but if I mention anything specific to the fall of 2017, like the first practice quiz coming up or hurricanes or anything like that, you can ignore all that information and just focus on the material. All right, so starting out, I just need to stop looking at the webcam. There we go. Get rid of it. So starting out, this is the first lecture that you should be watching. We have two this week in fall of 2017. The other one's on education. And both of those are lectures that I've come up with to sort of set the tone for the course. They don't really have a corresponding chapter in the book, which in the fall of 2017 is a good thing because the bookstore ran out of books. And that's sort of not their fault. We originally had this course capped at 40, and I think what happened is that's when the book orders went in and then they expanded the class. I haven't yet posted an announcement. I've responded to some of you through email that if you don't have to get your book from the UAB bookstore, I understand if you have a scholarship or something like that. There are some other sites. There was a couple on Amazon, new and used, but Barnes & Noble was out of them, so who knows what's high demand. They're just reserving them so they can rent them as opposed to selling them. All right, stop talking, Dr. Linville. Let's get into the lecture. All right, this lecture, the reason I go over it and where you'll want to come back and revisit this lecture is when we get to what I call mock case quizzes or a mock case portion of the exam. And what I'm going to do throughout this course is, for the most part, we're going to go over different things that happen in the forensic science laboratory and the way that the forensic scientists conduct the analysis. So those in law enforcement understand what's going on behind the scenes. If you're interested in becoming a forensic scientist, then it may help you make choices about your career. But in this class, I also like you to get you guys thinking, not necessarily like a scientist, but thinking in the terms of the way the science will be presented in court. And that is, sometimes on TV or the conventional wisdom is that evidence goes into the lab, the forensic scientist puts it into a machine, and then it spits out the correct answer. And in reality, forensic science is always about a comparison, and you're just sort of helping the jury to interpret the comparison that you're making. But in the end, the jury has to come to the decision about whether the fingerprint really did come from this individual, whether the blood stain did come from the defendant, whether this fiber did come from the suspect's van, and all the different types of evidence that we're going to cover in this class. So where this first lecture comes into play is we're going to not do a poll since we're online. That's more for on class. But I'm going to take you through the thought process that I go through in making up these mock case questions, and also the thought process that I want you to go through when you're trying to interpret the analysis of evidence and come to the correct conclusion. And basically, when I say come to the correct conclusion, I'm going to describe a case, and you're going to say either, yes, the evidence definitely came from the suspect or the suspect's van or whatever, maybe it came from the suspect, or definitely no, it did not come from the suspect. So those are sort of the three categories, and we're going to find that a lot of times we get a maybe answer. Okay. So like I said before, it's not always about just getting evidence, throwing it into a machine, pushing a button, and then it whispering the correct answer to you. Analysis is always about comparison, and we're going to see this in each lecture as we go through the different types of evidence. So you'll take a piece of evidence, and that's always going to be called the unknown. We'll run through some samples later at the beginning of the lectures, and one of the things I asked you guys to type in the chat box, I'm like, okay, is this our known sample or our unknown sample? Well, if it's evidence collected from the crime scene, that's always the unknown sample. And then you're going to compare that to a known sample, and sometimes this is obvious, like if you get a fingerprint at a crime scene, you compare it to the suspect's fingerprint. If you get DNA at a crime scene, you compare it to the suspect's DNA. Sometimes it's not straightforward. If you get a white powder at a crime scene, what do you compare it to? Well, if you want to know if it's cocaine, then you can compare it to cocaine. But if it's not cocaine, then you need to compare it to heroin. And you need to compare it essentially to all the potential white powders that it could be. So there it gets a little bit tricky, but it's always an unknown compared to a known. So we're going to run through an example using something that everybody's familiar with, hopefully. You guys still use pencils? Go ahead. You can respond in the chat to that. Do you use pencils? If so, mechanical or wood? I'm interested in that. And so we're going to go through a pencil example, and we're going to define what the unknown, what the evidence is, and what the known materials we're comparing it to. Okay, good. I like a good mechanic. Hey, I won't waste your time since we're online, but if you're not using 0.7 lead, you're a fool. Okay, 0.5, come on, it's going to break. 0.9, you're just a maniac. I don't know what you're doing. Why are you writing so thick? Okay. So we're going to talk about known and unknown. We're going to discuss the traits of these pencils, and then we're going to start comparing an unknown sample to a known sample and interpret it. Okay, so let's go ahead and get going. This is the case. It's stupid, sure. I know it's stupid, but it's an example. All right, so that's suspend our belief or disbelief or whatever it's called, and travel into a fantasy world where the Department of Criminal Justice is having a faculty meeting, okay? And for some reason, when we go to a faculty meeting, we are required to empty our pockets and our contents are photographed. Well, that makes a lot of sense, okay? So the following are photographs from a recent meeting. I haven't updated the names here. Curly is no longer with our department. Sloan's gone. Some of you seniors may recognize those names. Cobes is still here. Okay, look at that pencil. Miss Earwood, man, she doesn't carry a pencil. Hey, everything Miss Earwood does is permanent. Don't tell her I said that. I don't even know what that means. Okay, so you get the idea. We're at a meeting, and these are the pencils or pens that the faculty members are carrying. Okay, you don't have to take notes for this, so don't worry. Okay, ooh, good professional forensic science photograph. We photograph them with a scale as well next to a ruler. Okay. Later that day, oh my goodness, it turns out I'm murdered in my office, and underneath my desk, the following evidence is, do you guys see where this is going? Holy moly, it's a pencil. So now the thought is, if we can somehow demonstrate that this is Copes's pencil, then we can link them to the crime scene. Okay. If it's Miss Earwood's, she's linked to the crime scene, et cetera, et cetera. Now, ignore the fact that a lot of people are in and out of my office, and ignore the fact that, we're photographing pens and all that. The point is that we're going to compare this pencil, our evidence, with the faculty's pencils. Does that make sense to everybody? Okay, my first question for everybody, throw it in the chat box. This pencil, which was collected from my office and is evidence, is this our unknown sample or our known sample? Go ahead and answer in the chat box, and hopefully we get a couple quick ones. Okay, Leah gets in first, unknown. Everybody's agreeing with her. You guys are correct. It's evidence, so it's unknown. Okay, so the known samples we're going to compare it to are going to be the pencils from the faculty members. Okay, those are going to be our known samples. Okay. If this was blood, then I would say, this is blood from the crime scene, unknown sample, and then ask you what the known samples are we're going to compare it to. Okay, now the next thing in this little game that we're playing is I want you guys to name, again in the chat box, list some traits of pencils. In other words, if I'm comparing this pencil to Copes's pencil, what are some traits that I'm going to compare to see if they're the same or if they're different? Okay, color, good. Okay, we have red pencils, yellow pencils, black pencil. Length, very good. Brand, good. Sharpness, wood. Eraser, you guys are hitting on all of these. Let's see if we have them listed in the next slide. Oh, wait, I got ahead of myself, didn't I? Okay, we know that the unknown evidence is the pencil. We know the known sample. So listing the traits, which we're doing right now, there you go. Okay, so we hit on a lot of these. Okay, logo, the eraser shape, thickness. Okay, now we're going to go through each of these, and we're going to compare the unknown evidence to our known samples, and we're going to determine whether they match and what that match means. What is that? Well, let's go ahead and do it, okay? So here I have it listed. I need to squeeze my chat box so I can actually see the screen here. Oh, let me get my pencil or my pen out too. There, can I scribble now? There we go. Okay, so this is our unknown evidence right here, and we have the color, the length, the thickness, the logo, eraser, tooth marks, okay? So now, usually this is how it's done in a forensic lab. You just sort of go category by category, and if you can eliminate one of the suspects, then you eliminate them and you don't have to come back to them. Because if we can say it's definitely not Copes's pencil, then we don't need to compare any more of the traits, okay? If one's different, well, if it's the right difference, then we can eliminate. Okay, so let's go with color first. Okay, the unknown pencil and Copes's pencil are both yellow. Okay, this is a trait that matches. When a trait matches, okay, there's a certain process that we go through. But just using common sense, guys, okay, I'm asking you the question, is this Copes's pencil? Your responses are definitely yes, maybe, or definitely no. What do you guys think? Is it Copes's pencil? We got a maybe coming in, a lot of maybes. You guys are correct. Okay, but why is it a maybe? Okay, the response that I want you guys to sort of ask yourself and answer are, is that trait specific to Copes's pencil? Like, is Copes's pencil the only yellow pencil? Or another way to ask the question is, are there other pencils that are, and then you name the trait, yellow? And the answer to that is obviously yes, there are other pencils that are yellow. In fact, 2 of our other suspects have yellow pencils. So because it's not an individual characteristic, it's not specific to Copes's pencil, our answer is maybe. All right. If this was a mock case quiz and all I told you was Dr. Linville was murdered and the evidence at the crime scene was a yellow pencil and Copes's was also seen carrying a yellow pencil earlier in the day, what is your conclusion? Your conclusion is it might be Copes's pencil because other pencils are yellow. Okay, so that's what you do when the trait matches. All right, let's look. Okay, so yellow's not specific. We have other suspects with yellow pencils, and also it could be another random person with a random pencil, a random yellow pencil, that it could be as well. Okay, so it's not specific. Let's look at a difference here. Oh my God, I keep wanting to jump ahead. All right, so the answer is maybe. We can't say a definite yes because it's not an individual characteristic. Here we go. This is what I wanted to get to. All right, what do we do if the trait is different? Unknown pencil is yellow, Earwood's pencil is black. Well, it's actually a pen here. So let me ask the same question. Is the pencil at the crime scene Miss Earwood's pencil? Definitely yes, maybe, or definitely no. Okay. And we have a definitely no, and you guys are correct. Now, if you're thinking, well, maybe Miss Earwood had 2 pencils. Well, the question that I'm actually asking is the pencil found at the crime scene the same as Miss Earwood's pen that was photographed earlier on? Okay, and we know it's a definitely no. Okay, now when we get into talking about more scientific stuff, like whether TMB changed color or a negative for the acid phosphatase test, it might not be as obvious as this. So let's look at the process that we go through. Okay, because you go through a different process if the traits match versus if they don't match. Okay, so here, if they don't match, what we need to ask ourselves is, can that trait change over time? Another way to think of it is there any possible explanation as to why Miss Earwood's pencil would be yellow black at the faculty meeting, but then change to yellow when she's murdering Dr. Linville? Okay, so can a pencil's color change over time? And the answer, as you guys have answered previously, is definitely no. Okay. Pencil's yellow, Earwood's is black. A pencil can't change color. Her pencil could not change from black to yellow. And the change is important, as we're going to find out. So definitely no is the correct conclusion. Earwood's out of there. She's no longer one of our suspects. Definitely not, and we're eliminating her. So if that was the mock case question, find a pencil in Dr. Linville's office, compare it to Miss Earwood's black pencil, what's your conclusion? Yes, maybe, or no? You can answer definitely no there. Okay, on those story problems, it's not like true and false. Ooh, if you see the word definitely, that's not the correct answer. Sometimes, many times in this class, definitely yes is the correct answer or definitely no. Okay. All right, let's move on to length. I didn't change this. This should be length. Way to go, Dr. Linville. Okay. 13.7 centimeters. All right. Let's quickly go with Copes's. Copes's is 13.7 centimeters. Is it okay? So that's a trait that matches. We ask ourselves, okay, is that trait 13.7 centimeters specific to Copes's pencil? Well, the answer is no, because Sloane's is also, and you can imagine somebody else may have a pencil that same length. Okay, so pencil length, when it comes to matching, is the same as color. It might be Copes's pencil. Why? Because other pencils might also be 13.7 centimeters, just like other pencils might be yellow. Do you understand that? So we're not going to go through the example of a match. But here, Curly's is different. All right. And it's longer. Remember, Curly's was photographed at the faculty meeting, and the unknown pencil was recovered. The evidence was recovered later in the day in my office. So let me ask you this. Okay. Could that be Curly's pencil, or is it Curly's pencil? Definitely yes, maybe, or definitely no. Go ahead and answer in the chat box. Okay, so we have some maybes coming in. We have some definitely no's coming in. Okay, let's look at, whoops. Okay. All right. So we're discussing, I thought I had another slide here. Okay, the process we go through is the trait is different. Can the trait change over time? Can the length of pencil change over time? The length of the pencil can change over time, but it's important to note a pencil can get shorter if it's sharpened, but a pencil cannot get longer. Okay? So if Curly's pencil, which was longer earlier in the day, the question becomes, can it get shorter and shrink to 13.7 centimeters? Yes, it's possible it can change in that way. So Curly's, the correct answer is maybe. It might be Curly's pencil because the length of the pencil can shrink over time. Okay. Now, if it was a reverse, Curly's pencil was 13.7 and the evidence was 18.2, there we would answer it definitely could not be Curly's pencil because the length of a pencil can't increase over time. All right, again, that may sort of make sense when you're talking about pencils, but when you're talking about other forensic evidence like blood or drugs and using results from instruments that maybe you're not as familiar with right now, it gets trickier later in the semester. Okay, so make sure you're familiar with our thought process here. Okay, logo. Okay, we have the same for Copes and Curly. We're in the same situation here. Other pencils may also be Office Depot, but Sloane's is an Office Max logo. So let me ask you this. Is the unknown pencil Dr. Sloane's pencil? Yes, maybe, or definitely no? What do you guys think? Okay, and we're quick here. Definitely no's coming in. Yeah, the logo cannot change. It's just like the color. Can't change over time. So definitely no, we can eliminate it. See, we're making some progress here. Okay. All right, now we got the pencil or the eraser. Again, I've copied and pasted and kept forgetting to change this. This is the eraser. Okay. Boop. Pencil in the eraser in my office is like new. Copes's is worn down. Curly's is like new. With Curly, it's a matches. Could other pencils also have like new erasers? Yeah, that's possible. So Curly's still in the maybe pile. All right, Copes's is worn down. So here we go. Could an eraser be worn down earlier in the day and then magically repair itself when it's found in my office? No, a pencil eraser cannot change in that way, so Copes is eliminated. Yeah, you guys are right. Who are answering? Okay. All right, now we have bite marks. Bite mark found at the crime scene, but it's not on Curly's pencil. This, again, it's a trait that's different, but could it change over time? Could a pencil go from not having bite marks to having bite marks? That's possible. So that's another maybe. All right. So at the end of the day, when we're asking, okay, is this Curly's pencil? Then we have to sort of say that it's possibly Curly's pencil. Why? Why can't we say definitely yes? Well, because other people may have yellow pencils. Other people may have not 13.7 because his was shrunk. So other people may have yellow Office Depot pencils, if I'm remembering this correctly, with like new erasers. Okay, and for all the things that's different, it's possible that Curly sharpened his pencil and bit his pencil, so it also could be his because of that. Okay, so it's possibly Curly's pencil. All right, now, right now, I'm giving you a preview of something we'll talk about with trace evidence, and it's the difference between saying possible and saying likely. All right? It's okay to say that it's possibly Curly's pencil from a forensic scientist standpoint who's testifying about the traits of the pencil, but you want to avoid likely or not likely. All right? Just right now, the way I've described the case, okay, do you think that the pencil found in my office, do you think it's likely Curly's pencil, or do you think it's not likely Curly's pencil? What do you guys think? Go ahead and throw that in the chat box. Okay. Because if you're a jury member, then you can come to the conclusion whether it's likely or not likely. Again, you're probably going back. It was yellow. It was Office Depot. It had a new eraser. But the pencil in my office was shorter than Curly's pencil. Okay. And it had bite marks in it. So we get a couple likelies. You guys just didn't. You had the class with Curly before he left. You don't like him. Okay, what factors affect the likelihood? Well, why do you? Somebody just write like a brief. I don't know if you can do it in a sentence or two. Why do you think it's likely? Okay, and I'm going to give you a couple scenarios of why a jury's okay to draw those conclusions, but a forensic scientist can't. Okay. As a forensic scientist, I'm there to testify about my analysis, which is measuring the traits of the pencil and measuring the traits of the knowns, doing the comparison, and coming to the conclusion that it's possible. Okay. But when it comes to likelihood, things other than the analysis affect likelihood. And when I say things other than the analysis, I mean things like motive and alibi. But it's important to understand, as a forensic scientist, I'm not there to talk about motive and alibi. I'm there to talk about just the evidence. The defense attorney, the prosecutors, they bring in other witnesses to let the jury know about motive and alibi, and that's why it's okay for the jury to make a decision about likelihood or not likelihood, but not for the forensic scientists. Because let's add some information to the story. Okay? After the department meeting, Curly got on an airplane and flew to Seattle and attended a conference. Okay, now, is it likely or not likely as pencil? Well, in that scenario, it's not likely as pencil, right? Okay, here's another scenario. After the department meeting, Curly didn't leave for Seattle. He got in an argument with Dr. Linville and said, I'm going to murder you later today, but first I need to sharpen my pencil. Oh, I'm so angry, I'm going to bite it. Okay, if that was a situation, is it likely or not likely? Yeah, now it changes to likely. See, but as the forensic scientist, I don't know about the argument. I'm not there to testify about the argument or anything like that. It's just the evidence. So what I need to do is tell the jury what I did, and I can help interpret it. I can give the jury some information as far as how many Office Max pencils were sold. If it was an extremely rare pencil, then that seems to be more likely. If it's extremely common, maybe less likely. Okay. So possible is what a forensic scientist can say. Likely or not likely, you probably want to avoid that and leave that to the jury. Okay. This is going to come back. Now, here's everybody's favorite thing. Let's say it was Curly's pencil. Okay, does that mean he's guilty of the murder? Yes or no? Well, again, this is the jury's decision. It's not your decision as a forensic scientist who's testifying, because maybe he has maybe somebody stole his pencil and tried to frame him by leaving it at a crime scene. Okay, maybe he was in my office. biting his pencil while we were arguing, dropped it on the floor after sharpening it, but that still doesn't mean but then he left and somebody else, my ex-wife, came in and murdered me. Okay. So again, the forensic science, it's all only about the analysis of evidence, and you have to help give the jury the information they need, which is, did the traits match or not match, and what is the rarity of that pencil? How common is that pencil? And then you're done. It gets turned over to the defense attorneys, prosecutors. Okay. So I'll try to trick you in assignments and ask you about guilt or innocence and ask you about likelihood or not likelihood. Don't fall for the trap. All you can say is it's possible. You got to give me some information. Okay. And you know, this I sort of go on and on until the bell rings. If we had a bell, they should put in bells at UAB, shouldn't they? That's great. Go on and on until class is over, but I'll keep it short. You know, I asked my class, I'm like, does anybody in here hate science? And sometimes, like, people, yeah, I hate science. You know, whether they don't like, you know, had a bad experience in class or think that it's, you know, used to prove things that can't be proven. And my argument is always, hey, don't hate science. You can hate the scientists, okay, but don't hate science. Science is just an organized way of thinking. Science is just a way of structuring your analysis of that pencil so you can come to a proper conclusion of whether it's possible or not possible. But the likelihood is just sort of the conclusions that the jury or the defense attorney or other people draw based on that data. Okay, so science is all about collecting data in an organized fashion and presenting it to people so they can make conclusions. Okay, science is all about organizing your observations. You know, because it's not like for curing cancer. Is that in the next slide where I talk about? Okay, the cure for cancer is not going to be like some nerd comes out of a lab, found it. It was a plant in the Amazon jungle. Who would have guessed it? All you have to do is eat it and your cancer's cured. No, that's not how it's going to be. It's going to be people making observations. You know, like, oh, when we apply this chemical to a tumor and attach a DNA sequence that allows it to target and attach to the mutation that's causing the cancer, it seems to prevent the cells from growing and, you know, stops the growth of the tumor. Like, all of those decisions are made by little studies and observations about how it best stops the tumor and what works and what doesn't work, okay? So the science is all about, you know, making these observations, and then the conclusions can just be thrown all out of whack. And the reason why politics are so frustrating to watch is you get people on TV arguing about the conclusions, and they never really discuss, you know, the data that it's based on. Or they'll just give one source of data, and it's the one study that supports their argument. Climate change caused Hurricane Harvey. Here's a paper that Al Gore wrote. Climate change doesn't exist. Here's a paper some idiot wrote, you know. Okay. So it's just, I don't know. I think our world would be better off. Well, not our world. That's a little bit. Hey, let's go right over the top. Our world would be better off if, when we're having discussions, we focus on the observations and the measurements, even though it's kind of a nerdy thing to do, as opposed to just drawing conclusions that make us comfortable. I'm going to find somebody who agrees with my conclusion, and good. They did the work on finding the data. I'm just going to agree with what they got. Anyhow, I mean, that even boils down to like arguments you're having with your wife, you know, although I guess I don't have much success there, but, you know, don't argue about the conclusions, you know, figure out okay, let's wrap it up, Dr. Linville. Global warming, evolution, medical research. I think I touched on all those. Evolution exists. Evolution is bogus. Well, let's talk about the data he's here. Okay, I mean, you know, what about dinosaurs? First of all, let's talk about that. Oh, they were planted here. Okay, if you think they were planted here by space aliens, then I'm probably not going to listen to your conclusion as much as, you know, something else. Okay, anyhow. All right, that's it. Hey, if you guys have questions right now, go ahead and throw them into the chat box. I think, Ebony, don't go anywhere. I think you're one person who jumped into the room after I started taking attendance. But everybody else, I have you on the attendance sheet. You're free to leave at this point. I'm going to leave the recording running a little bit longer. So if you have any questions about the lecture or the class, you can ask them. I'll keep the recording going so the answer is there for everybody to listen to. And then I'll stop the recording. And if you have any questions that you don't want to be on the recording, then you can ask me at that point. Okay, but at this point, everybody's free to leave. You just, I don't know, close the window, you leave, and that's it. I'll see well, actually, I might not see any of you for the rest of the semester because you already got your 5 points. But just know that you are free to attend any of the live lecture. You won't get extra points for it, but some people just like to, sit in live as opposed to watching the recordings. And next week, I'll have my hair cut. You won't have to look at a bunch of pillows. I'll work on the backdrop a little bit. It'll be great. All right. All right, so let me cancel out of this. All right. No immediate questions, so I'm going to go ahead and stop the recording. So if anybody has any